Dear friends, welcome to the new video. This video is about the solution or how to solve the numericals. But in this video, we will limit the discussion only about the numericals of kinematics or the motion problems related to the motion. So whenever you are going to solve any kinematics problem or problem related to the motion, then follow these rules or the instructions. Number one, first of all, read the description of the numerical at least 2 times, 3 times, word by word. This will help you to build up or to basic image or the basic concept related to the motion or related to the kinematics. Secondly, draw the figure. Figure means you have to draw the figure in your mind. It is not necessary that every kinematics numerical will involve the diagram or show the diagram. The diagram you shall have to draw the diagram. You will draw the diagram and you will think in your mind, rough diagram. In your mind, if you think it necessary, then you can draw it at any rough corner of your page or of your copy. Next thing is that every numerical related to the kinematics or related to the motion involve the same common type of diagram. Every numerical. Like it might be, this is the common diagram and normally involve each and every numerical of the kinematics. For example, A is the starting point or initial point where the body is at the start of the motion, and now the body comes into motion and moving in this direction. Now in the beginning, at the start, whatever the velocity of the body is, that velocity is called VI, initial velocity. And in Cambridge books, it must be in mind for the Cambridge students that in the Cambridge books, initial or starting velocity is given by U. U is the initial velocity in the Cambridge books and VI in other books. Now the body start moving, and after the time interval t, after some time t, t is the time interval. This is the time interval. During this time, body reaches to the point B. Body come over here. Now at this point, the velocity of the body is Vf. F mean final velocity. And in the Cambridge books or for the Cambridge student, final velocity is given by only V. So V is the final velocity for the Cambridge student. And A is the acceleration gained by the body during this journey. And as well as the acceleration means the velocity of the body is increasing and it increases from Vi to Vf, or it increases or changes from U to final velocity V during the time interval t. So t is the time interval, and during this journey the body covers the distance of s or displacement of s from A to B. So s is the displacement or the distance covered by the body. So this is the common and the very same common type of problem which is normally involved in every or all kind of kinematics numerical, especially the horizontal motion, not the vertical motion or falling down. Now the third thing, after drawing the rough figure, after reading the description, read the word for word and mark out or pick out the numeric values. You can see the numeric values, and every student, if you do not don't know the physical concept, even then you can pick out or mark out the numeric values like 5 meter, m is a meter, like 3 meter per second, you can note it or see that, 6 meter per second square, 10 second, etc., etc. So after noting these numeric values, just try to remember or think which quantity comes to your mind when you see m. M is the unit of length, height, diameter, or whatsoever. In short, in brief, m is the SI unit for length or distance displacement. So m will remind you that 5 meter may be the displacement or the distance covered by any body. Similarly, meter per second will remind you, or you try to think yourself, which physical quantity come to your mind. Meter per second will remind you that meter per second is a SI unit of speed, and it is also the SI unit of velocity. Similarly, meter per second, 6, 3 and 5 are the magnitudes. So they may have any value, and don't care or don't worry about the numeric values, and just focus your attention only to units, m, meter, meter per second. Now meter per second square. Meter per second square. Meter per second square is it will remind you that meter per second square is a unit of acceleration. And similarly, this is 10 seconds, so ignore the magnitude and just focus your attention to S. S is a second, and second remind you that 10 seconds will be the time interval or time taken for this event from going from A to B. Meter per second square is the unit of acceleration. Hence, these numeric values will guide you that which physical quantities are involved in this numerical, like meter. Meter will involve you that it may be the displacement or distance of any body, it may be the height of any body. Meter per second involves you that, remind you that it will be or it would be the speed or velocity of any body. Meter per second square, acceleration 10 seconds means it will remind you that it would be the time interval or time taken by the body from going from here to there. Now assign the symbols. Assign the symbols mean this meter will remind you that it is a SI unit of distance displacement. So assign the symbol S to 5 meter. Hence S is the symbol for distance and displacement. When you have decided or you have come to this conclusion that 5 meter is a distance or displacement, that's why assign the symbol of distance or displacement. This 3 meter per second remind you that it would be or it is unit of speed, and the symbol for speed is and symbol for velocity is. Symbol for both speed and velocity is V. V is the symbol for speed, and V as well as V is the symbol for velocity. So 3 meter per second, in 3 meter per second remind you this, and so you will assign or reassign the symbol of speed or symbol of velocity, this one, to meter per second. Similarly, meter per second square, it will remind you that this quantity is acceleration, and so we will assign the symbol of acceleration to 6 meter per second square. 6 meter or 8 meter, whatsoever. If 6 meter, then 6 meter. If 8 meter over here, then 8 meter over here. These are random. Now, after passing these 4 giving symbols, now once again read the description and look or find out which physical quantity is required. For example, in the numerical, you are asked calculate the force applied, calculate the air resistance, calculate the tension. So air resistance and tension both are the technical name for force. It's mean when you are set to calculate the tension, then you are set to calculate you are asked to calculate the force. Calculate the friction force. So tension, friction force, applied force, accelerating force, it's mean you are asked to calculate force. So write down the symbol of force. Now if you find the word how fast, then how fast is a bit difficult to understand. In simple word, how fast mean what is the speed, what is the velocity, find the velocity of the body. So if you see the word how fast, then it's mean you will calculate the speed, or you will calculate, you have to calculate the speed or velocity, then v is the speed or velocity. Similarly, if you see the word how long, then how long is, once again, it is a bit difficult or little difficult term to understand. So how long mean, long is a time space or time dimension. Long shows the time measurement. So how long mean how much time is taken. Find out the time interval, find out the time taken when you see the word how long, and then write down T this over here. So mark out the physical quantity which is required to find out. Now some more or some other keywords that must be noticed when you are reading the description of the logarithm. If you see the word from the rest mean the body is starting the journey from the rest, and it's mean the initial velocity or starting velocity of the body will be taken as 0. If vi initial velocity, or in Cambridge books initial velocity is given by the symbol u. So from the rest mean put 0 or take 0 for initial or for the initial velocity or initial speed, either by symbol u in Cambridge or in other books vi. To the rest mean come to the rest. It's mean body has come to the rest, body has come to the stop, and the journey is ended. The journey has come to an end, body has come to an end. It's mean from the rest mean once again put 0, but this is final velocity 0. So put Vf is equal to 0. This is F. F mean final velocity. F stand for final. And in Cambridge books only V. Only V is the final velocity. U is the initial velocity. V is the final velocity. So to the rest mean put final velocity is equal to 0. From the rest mean initial velocity is equal to 0. Similarly, uniform velocity, uniform speed, constant velocity, constant speed. There is another name, steady velocity, steady speed. So uniform velocity, constant velocity, steady velocity, steady speed, or the terminal velocity. Though there are the 4 terms: constant speed velocity, uniform speed velocity, terminal speed velocity, and the steady speed velocity. All 4 have the same meaning, and it means only one thing. Whenever you find the word uniform, constant, terminal velocity, steady velocity, then do understand that velocity of the body is not increasing, not decreasing, and the body is moving with the same value, 20 meter per second, then 20 meter per second, then 20 meter, 20 meter, 20 meter, 20 meter. It's mean the change in velocity 20 to 20, 0 change, 20 to 20, 0 change. And in this case, velocity is not changing, so the acceleration of the body always be taken as 0. Now, if you see the word drop mean it is any body and you release it or drop it and it's fall down under the force of gravity, it fall down under the force of gravity. So when any body is dropped or releases and it is pulled by the force of gravity and it fall down to the ground, then the acceleration of freely falling body is the value is not told to you, not given in the books, sorry, not given in the questions, and you are responsible to think about the acceleration of the freely falling body. With this acceleration, you are responsible to know that what is the acceleration during falling motion, and that acceleration has two names. Symbol is a small g. This is the small g. This is the small g, and this is called acceleration due to gravity, gravitational acceleration, acceleration due to gravity, and the gravitational field strength. Acceleration due to gravity or gravitational field strength. There are the two numeric values. In some books 9.8 meter per second square. In Cambridge books or for Cambridge student, it is also called gravitational field strength, and its value is taken in Cambridge studies 10 Newton per kilogram. 10 Newton per kilogram. Now let's come to the next point. Okay, this is the point 7. Now this is the data that you have prepared after reading the description of the numerical. It is arbitrary or random. So looking at the data that you have prepared from the description of the numerical, think that in which formula these values are able to be fit, or these values can be put, these values can be fit. So what is that formula? So try to remember that what are those formulas that you have learned in the theory of kinematics in your chapter, in your books. Here not all the formulas are written over here, only few formulas are discussed over here. There are many other formula other than this that you will read in your chapter, in your book, in your syllabus. And these formulas are S is equal to ut plus half at square. This u is the initial velocity, and in Cambridge books it is written with u. But in other books, u is not written for initial velocity, and here the vi is the for initial velocity, and it is for Cambridge students. Similarly, 2as is equal to v square. V is the final velocity in Cambridge students, and u is the initial velocity. But same formula is written over here. Vf square minus vi square. Square of the final velocity, square of the initial velocity. So both formulas are same. Square of the final velocity, square of the initial velocity. This is for the Cambridge student. This is any other board or any other book. Similarly, final velocity v in Cambridge, final velocity in other books, u initial velocity, vi initial velocity, at are the same in any other system or in Cambridge system. In both, acceleration is given by a. And similarly, f is equal to ma. It is similar in both. In Cambridge system, f is equal to ma, and the same expressions, same symbols are used in any other board. Only the difference is the symbol for vi and vf. Now, looking all these data, just try in which in these formulas these can be fit. For example, 5 is the magnitude and meter is the unit, SI unit, S is the displacement. So look for the symbol S. So here is S, here is S. It means we will put 5 meter if we are using this formula. So we will use 5 meter over here. If we are using this formula, so we will put the value of S 5 meter over here. Similarly, if V, speed or velocity, 3 meter per second. So look for the symbol for velocity. So symbol for velocity is V. V. Hence we will put 3 meter per second either over here or over here. Similarly, A is the acceleration. So look for the symbol of acceleration over here. We can put 8 meter per second square over here, over this say, over this say, in place of this say, in place of this say, in place of this say, and in place of this say. 1, 2, 3, 4, and there are 4 symbols for acceleration, and we can, whatever the formula you are going to use, you can put this, you will put this 8 meter here, 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 or this. Similarly, as we said that when you see the word how long is the time measurement, so time interval, so 10 seconds. So look for the symbol of T. In which formula symbol of T is involved? So T, it's mean we have 2 formula, one of this and one of this. We will put this 10 seconds, either this one in place of this T or in place of this T. So we will have to use any of one this formula, not necessary that all these formula at the same time. So it is never possible. Suppose if we put the mass 8 kilogram over here and acceleration 8 also over here. After multiplying this 2 8s, 2 8 mean it is 8 mass and it is 8 8 the 64. So it's mean 64 Newton. So 64 Newton is the value of applied force, or hence we find the value of 64 Newton is the value of force. So putting these values in the data in any of the formula which is suitable, we can find the value of whatever the physical quantity is required. For example, value of acceleration is 8 meter per second square. We put this 8 in place of, this is the acceleration. So we will put 8 meter 8 in place of acceleration. This is 8. Similarly, this is mass of the body 8 kilogram, also 8 kilogram. So put this 8 in place of mass. So m is the mass, and in place of m we will put 8 once again. So 8 into 8 comes around 64 Newton. Hence we have find out 64 Newton is this value of force, or the value of this force is 64 Newton. Hence, putting all these values, whatever in the suitable, which one is suitable according to this data, we can find the value of the physical quantity, or we can come to the answer. Hopefully, you will find it helpful to your studies, and thanks for watching it, as well as must subscribe the channel